Then I talked about bases. We talk about see the decimal numbers. We deal with decimal numbers throughout your life, and when you do in computers handle binary, sometimes octal and hex and so on, and base 16 and so on. So in Python, earlier in our when we learned Python Fortran programming in our initial life, so we used to write a elaborate program to to convert one binary number into a decimal number, and decimal to binary and octal and so on. So you divide by 2 and go on checking the quotients and remainders and things like that. You can collect those numbers, zeros and ones, from the down to up, and then you form a binary number, etc., etc. This is a trick. You can check it. Young people who are studying in schools and colleges can actually do it yourself, and you get the fun. But here you don't have to write a program. Program is good. I mean, you write following a certain algorithm, the logical structure, how you arrive at the decimal to binary and so on. But you don't have to write it here, because if you understand that is well, but it's sometimes we teachers say that it's not good because everything Python is doing, what you will do, nothing like that. But you use certain better things in that. So if you write bin, you write some number. Some number is of course a decimal number. If I don't say anything, bin means it will convert is a binary. You see this binary. So the number will be, this is the number. This is the number. And 0 is for the sign, plus, and the B for binary, and the rest is the number. If you now copy this number, so every number will start with 0. Oh, if you write, say, suppose you write, I mean, it is not copying. Copying is not being able to do. 0B, you can also put capital B, doesn't matter. And see, you put 1, 1, 0, 0, 0, 1, 1, something, something. It's binary number. So if you write this, it will get back to decimal number. So thus, it's very easily, you can convert from one number to one something binary to decimal, decimal to binary. If you write, say, oct, these are all you will find it in the built-ins, okay? Oct function. Built-in means I am not referring any address, where from it is coming, it is inside. So oct, you write some, say, number, say 13, decimal number. So it will give you the octal number. So you see the octal number is, so you get back 0, write 0, and the next is O for octal. You could write 0, small 0, you could write capital 0. See, the shapes are different, okay? So you write 1, 5 to get back the decimal number again. So octal number, if you type, you get the decimal number, but for from decimal number to octal number, you have to always give this function oct. So then there is hex also. Hex, say, I say hex of, say, 22 is number, it will give hex. So if you write 0x16, you get back the decimal again. So this way it is now very easy. If you write bin, and inside that you write something, say number, some long integer, so it will give you a, immediately it will convert to a, it's a something binary number. So this is something important. And yesterday, another one, I have not talked about another kind of number, which some of you may not be interested in. That is a complex number. We in physics or in the other branches of basic science, sometimes we are in necessity of complex numbers. In mathematics, of course. If there was no complex number, there would not be any quantum mechanics, and there would not be the kind of civilization. So complex number is very, very important. Complex number is something, some negative number, you take a square root of that, say. So if you write square root of -1, so that is the symbol we call I, small I. So I is, I cannot write square root, but if you the symbol I cannot write here, the square root of -1, okay? You can import math and check, but anyway, square root is, suppose you can import math, So if you write inside math, there is a function called square root, and let's see whether it can do. So you can always take a square root of a positive number, but here you are taking a square root of -1. Means if you can take a square, I mean, you take a square root of -1 and take a product with square root of -1, the answer will be -1. So the square of some numbers is actually negative. That is that is called imaginary number. So let's see what it does. It doesn't do here. For that, you have another module which is called C math, complex math. But I'm not going into there. Arunahoda will tell in details tomorrow. Okay. So anyway, but if you write, say, for example, I say I is the symbol. Simple I is the symbol for anywhere in the textbooks is for imaginary part. The complex number consists of two numbers. First, real part, some real part plus some imaginary part, right? Like xy. If you plot the number in xy plane, on the x-axis you plot real part, and then the y-axis you plot the imaginary part. Okay, something which is which may it may appear to you from uninitiated people that it can be something abstract, but be it abstract, it will be useful for later. It will slowly understand. The I symbol, by the way, was given by the very legendary, one of the top 5 mathematicians of the world, Leonhard Euler. But you see, the engineers have changed the symbol in computer as J, because I will conflict with some other things. In physics also, I is sometimes not written. I is for I current, ampere, and things like that. So anyway, I write J. But if you write J, you will think of is a variable name, because J is some alphabet. So rather you call it something prefix with J. If you write 1J, so that is it. 1J is text. So 1J, I told you the variable name should not begin with 1. It is not a variable. J is a special symbol reserved for square root of -1, right? So if I write now, say 2 plus say 3J, it's a complex number. You type 2 plus 3J. You don't give a blank. It has to be prefixed with it. So this is complex. You see, this is a complex number, and this is the real part. This is the imaginary part. Even say 2 is a real number, but if you type say 2 plus 0J, something you have to give, some number. So it is a complex. So basically it is 2 plus 0 means the imaginary part is 0, but the total number is a complex. Okay. So anyway, and you can write anything. You can write, say, you write, say, x equal to some 3.6 plus something point something j. So it's anyway a complex number. Okay. So you will eventually get to see the complex numbers. Of course, I can tell you some built-in function. See, suppose if I write, say, x equal to 2 plus 3j. The real part is 2 and the imaginary part is 3, right? Okay. And if I would write, say, y equal to 2 minus 3j. So just I changed plus to minus, and the y will be called the conjugate of the variable x, conjugate of the number x. So if I now try to multiply xi and y, young students who are here who do not know complex number yet can verify it yourself by hand on your notebook. You just try to multiply 2 into 3j, 3j into 2 minus, and 3j, 3 into 3, and j into j is similar thing will be added with similar things, and so j will be the j square will be -1, and j will remain. So if you write x star y, you will see the j's will cancel out, and the j square is -1, and the result will be, it gives a complex though, but the imaginary part is 0. Actually, the product is 13. Basically, the real part is 13, the imaginary part is nothing, so the product is 13. But so the peculiarity of a complex number is that if you multiply with, not peculiarity, this is obvious, you multiply complex number with this complex conjugate, the result will be a real number, of course, always. You can check it on your writing on your notebook. And you will find the complex algebra is a very, very fascinating thing. Okay, so now if we write ABS of, we don't do that, we ABS of X. So it actually does is that it does square root of 13. That means, see, if you have X, and probably it will, I don't know whether it will, no, it won't do, there is a, let me see if this conjugate is there. Conjugate of X is there. No, a conjugate is not there. It is in CMath. In math, CMath dot conjugate, it will be there. But ABS is what it does. It actually takes X with X and Y are basically Y is a conjugate of that. It takes the product and then the square root. So it does the absolute. So you get to know the absolute value of this. Okay. So there are all these kinds of things. Also, there is a function called complex built in. If you write 2, 3, if you write 2, 3, and it will tell you, give you another 6. Again, the similar way, it's a complex number. And one fantastic thing about Python is that you see there are 3 kinds of numbers up till now: integer, and then the float, and then the complex. You can think of the integer is a narrow number. You can think of it, and with it you put a dot and do some extension. It is a little wider number. That is a float, and you take this as a real number.
Which is, to add one thing,
yeah,
you wrote it correct. Instead of CONG, you type X dot conjugate.
X dot conjugate. Okay, let's see. X dot conjugate is there. No, okay. Maybe there. I have forgotten. Conjugate of X, right?
No, just bracket open. X, you have written X dot.
Conjugate of X. Oh, it is that. That means you have to take the product of X dot conjugate. That means it will give the product. But then again, you have to take the square root of that. Okay, then to get this absolute value. Okay, the conjugate function is there, right. Okay. Let's see what the conjugate works. Conjugate works. No, the conjugate doesn't work. It is an attribute kind of thing of X. Well,
conjugate is a method on the class.
On the.
It's a method on complex class.
Yes, it's a complex class. Okay. So this way we'll figure out what how works, how and what it is. But one thing you remember for the beginners. So you see there are 3 kinds of numbers. The integer you can think of as a narrow number. It's a little wider is a float, and the even wider is a complex number, because complex number has 2 parts. You can write something, point something, plus or minus something, point something, and then j. So it's always a provision that is a real part can be a float, and the integer part is real. The imaginary part is also float. So you can think the complex number is even wider. So when you actually deal with some different numbers, the Python is very clever. It will understand. It will always make it wider. I give you one example. Earlier we failed to actually sum with a string with a number, but now we'll see. Suppose a is a integer. Suppose it's integer. B is something dot something, so it's a float, and C is a something dot something dot something, say plus something dot something j. So A, B, C are 3 different kinds of numbers. But if I write A plus B plus C, that we do an arithmetic operations, it will give a complex number. It will understand immediately that first it will make it a complex. So the widest number is this. So it will convert, everything is complex, and then add the corresponding terms. And this is the real part is up to this. It didn't follow this, the aesthetics I was talking about. It's just write plus here, okay, and plus this, okay, this is the imaginary part. So this way you are actually doing doing arithmetic with all kinds of numbers together. It will always find in arrays tomorrow, day after tomorrow or so, in list and something like that, in not list, arrays and things like that. These you declare different kinds of numbers, real and the complex and these things, and it will always convert the all the numbers into the widest thing. So you'll always remember this when you will actually doing the program. I'm almost close to 2 hours, but I have lots to say. So I'm just telling you one thing. These things you came across the range function yesterday. Range is to create a collection of numbers. In Python 2, the range, if you give, say, earlier, yesterday, Ananda was showing that if you write, say, 1 to 10, say, it will create numbers from 1 to 9, and here the step size I have not given. You can give it, say, 2. Say, it will create numbers 1, and then 1 plus 2, 3, and then 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, but it cannot cross and touch 10. Okay, so it will create a number, but in Python 2, difference between Python 2 and Python 3, I'm talking about just this range. This range in Python 2 will give you a list of numbers. What is list? Tomorrow you will see in Aruna Bodhikari's class. But here it creates an object. Let me type it range. Let me first put a variable. Always refer with a variable. That's good. 1, 10, 2, this, and then you type x. You see, it is not saying it is a list. It is a range. That means range is, you can think of it is an iterable, some object it has created. But in Python 2, it automatically gives you a list. You can convert this and the list. So you can write list is a function built in. You can write x. It will produce a list. If you write tuple, tuple is a tuple of numbers. These are very serious differences. All the numbers, but it is begins with square bracket. It is between two first brackets, then parentheses. Tomorrow, Aruna Bodhikari will tell all the details of those things, and these are very important for Python. So even if there is a function called set, on kind of thing, then if you write x, it will begin with a curly bracket. So you see the same numbers. Sometimes with square bracket. I mean, in your good old school days, we used to say this is the first bracket, this is the second bracket, this is the third bracket. So actually, this is square bracket, parentheses, and curly bracket. Anyway, so you see, you can convert them in different explicit forms of this. Okay, so that's one thing to mention. And in Python 2, one thing before I forget, I just tell you that in Python 2, the input function used to take values from outside. The input function does not take it as a string in Python 2. It directly takes as a number, but here it does. And another difference is that print function. Print is a function in Python 3, like all other functions. But in Python 2, if you write, I can go to Python interpreter and show you. If you write this hello world or so, it will work. But here it will not work. Here Python 3 it will not work. Okay. But Python 2, you don't need print is a command like this. Okay. And another thing is that if you write 2 by 3, it gives you the kind of entire in decimal in float. But in Python 2, it will give you just 0. That means the quotient part. Okay. These 4 differences are there. We can even write into the group again and give a list. Only these 2 differences. Otherwise, there is no other differences you can fill at the moment. So what are the differences? Print statement, input statement, input the function, print function, and the division by 2 numbers of 2 integers. And in Python 2, what you do is that and in all other computer programmings, like we learned from the heart, that in Fortran, C, whatever, the best way to avoid this ambiguity, whether it is Python 2 or Python 3, whether it will work or not, it is better always you write 2 by 3 point. You try with in Python 2. It will give you in Python 2 the correct, I am not correct, this float part, the result. Okay. And you can always write 2 by the float of 3. You can also write. You could always write, say, x and y equal to, say, 2 and 3. You could write always a float of x by y, or float of x by float of y, or x by float of y, whatever. Python is so clever. One thing you, not Python, in all other languages, it will understand you are actually asking the answer in float. So these are the serious differences between the two versions at the user level. Otherwise, don't have a headache. Whatever people say, forget that. This is not good, this is not bad. Whatever Python 3 has new things, features, and etc., that are something sometimes you will not be of any use. But it is your option, whatever you want to use. So I have now introduced you mostly the ingredients, so-called, that will be useful for your writing program. Now, take a little 1 second breath, and I can now tell you some basic structure of Python. That means for every computer program, you do certain things, like you write as a code, and in that code, it is not always plus, minus, or something mathematical operations. You follow some logic.
Can we stop here for a minute and take Vijit? 1 or 2 minutes and take some questions, and then you go for the next topic.
Okay, or is it not that we can give a break or something, come back, or we finish this? What is the general opinion? I can.
Well, if you are breaking for questions, people can always take a break if they want.
Okay, but
moreover,
okay.
Let me just ask: do you really have a lot of other things to say today, or you can also continue tomorrow?
I would talk about. I would talk about for loop, if logically if, and then
that's a
fantastic thing with random number. Huge thing. I could if I would get another half an hour, then I could do the justice, I think.
But I think it's best that there are a few very serious questions which have come up during this.
Okay.
We can discuss
and
those.
You can also answer that.
I really want to answer a few of them, actually. And more importantly,
you answer them.
If Navoda allows you, you can continue on, not tomorrow really, but on Monday. Take the first half.
We can. Can I tell you one thing instead? That we can take a 10 minutes, sharply 10 minutes break, and by that time you can have tea and can answer the questions. I can also have tea and come back. Can we do that, or you can stop altogether? We can stop altogether, no problem.
No, you don't need to stop altogether. Come on. Depends on
because the questions, I can see the questions. You can answer all the questions, so you are there. So
no, that's fine. I can answer the questions. I want to answer a few of the questions because there are certain questions which have come up.
Yeah. Can you answer them? Okay, but then I stop talking. I mean, then you answer.
The only concern I have is if and the for are actually very, very important. So I don't really think that you should rush them at the end of the day.
Yeah, yes, if and for are very, very important. I just have to introduce anyway. I mean, so this is very important because otherwise,
why don't we just take some time to finish that off, and then we can take a break and questions. Hello.
Yeah.
No,
tell me.
One possibility is you will take around half an hour, right? After that, we can.
I'll take another half an hour. I'll take if I come back in 4:10, say, not 4:10, 5 already, no? 5:10. If we come back in 5:10, sharp at 5:10, and I can finish it 5:30, I think. I'll take 20 minutes.
Fine.
Okay.
Thanks.
So let's take 10 minutes break. I'll make tea. Nobody at home, so I'll make tea and come back. You better answer those questions. Okay.
The workshop is continuing. You are taking a break.
Anybody who wants to 10-minute break can, of course, take a break.
Yeah, 10 minutes break. I think 10 minutes break. Okay, so we come back in 10 minutes. Okay.
There is a question. We can have a 10-minute break and resume the workshop. I'm pretty sure people will not really want to go on for a very long time. So in the meantime, now we have a 10-minute break from the actual talk. What I will do in this interval is that I will answer some of the questions that were already raised in the chat in between. Questions relevant to what was talked about here. Anybody who doesn't want to hear that, or anyway, I'm going to upload this video later, so you're not going to miss much.
I'm leaving. I'm leaving for 10 minutes. I'm leaving for 10 minutes.
Yeah,
Okay.
yeah. Okay, go ahead.
Okay.
So the speaker has left now. So I will just take 10 minutes till he comes back to answer a few of the questions. If any of you want to have tea or some other break, please do that. You're not going to miss a lot if you don't listen to me right now. You can always listen to what I have said in the video later if you want to. Okay. So let me just point out that at the very beginning, okay, what I'm going to do is I'm going to take over the presentation for a while. Okay, I am taking over his screen simply because I want to show you something else. Well, I want to type myself and show what happens. Okay, so I hope my screen is visible now to everybody.
Clearly. Ananda, clearly.
Yeah, okay. So a question was raised during this is what is this slash quote? Let me clarify this. When you use a slash, this particular slash is called a backslash. This is a front slash. The slash that we are using here is a backslash, a slash which looks like this. And when you use this backslash, that's called an escape character. This is nothing unique to Python. Almost every programming language has this. The basic idea is that when you precede a character by the backslash, the so-called escape character, the meaning of the character after that changes. So, for example, I'm just going to give you some string examples because strings are what we have seen so far. So let's say I just type print a string T A. Okay, let's say A T B. This of course just prints ATB. And here A, T, and B simply mean the characters A, T, and B. That's it. However, what we can do is put a slash in front of the T. This means that the actual meaning of the character T has been escaped and it means something else now. In particular, slash T means a tab character. So if I print this, you will see that the A is no longer, A is there, but the T is no longer there. What you have is a tab space in between A and B. So basically what the backslash does is that it escapes the usual meaning of the character and changes it to something else. So for example, so the important point that was made there is this. Suppose I wanted to write this. Now I'm going to get an error with this. Why? Because quotes are string delimiters. They begin and end strings. So here I've begun a quote with a double quote, a string with a double quote. I've written A. The moment Python sees the next double quote, it thinks that the string has ended. So it thinks that within quotes A is the string. And right after that, there's a B with a single quote hanging around, single double quote hanging around. And Python cannot make sense of anything here. But if you wrote this, instead of writing that, if you wrote this, usual meaning of the quote as a string delimiter is escaped, and as a result, it's just treated like the quote character. So, well, you see the two things are opposite. In ATB, T actually meant the character T by itself, slash T meant something else. Whereas, as far as quote was concerned, quote actually does not mean the quote character. Quote means something else. Quote means something which you begin or end a string with. Slash quote actually changes that meaning to the character. Similarly, there's one more example, and I will be done with this. So slash n actually is what is called a new line character. This doesn't mean the number n, the letter character n, it means a new line. Slash n means new line. So the meaning of the character n has changed to new line. And so when I print this, I see A followed by a new line followed by B. So this is basically what is happening here. Okay. So as you may have noticed, what has happened is that we have actually changed the meaning of this A NB to A slash NB has changed the meaning of n. And this is exactly what the escape character is for. So slash quote means literally the quote character and not a string delimiter. Okay, that was one question that was raised. And is this okay, or does this explain that slash quote thing? And slash quote means when you type slash quote, you have to type slash and then quote. When I say slash, it means backslash. Okay. Now that was one question. Another question that was really raised a lot about eval. And first of all, why is it that in Python 3 we have to use eval? Now eval does not really change its input into a string or an integer or something. What it does is evaluates. That's what eval means. So when you write 2 plus 3, for example, you get 5, right? If you were to write this is not the integer 2 plus the integer 3, it's just a set of 3 characters, 2 plus and 3. So it's treated just like any string and is shown as that. No calculation is done. However, if you carried out this eval on quote 2 plus 3, what it does is Python essentially takes the expression within this strings in the string. So eval always takes a string as an argument, and Python always just evaluates it as if it were a Python command. So if you were just to say 2 plus 3, whatever happens, eval essentially does that. Okay. So if you were to evaluate, so if I just put 14.3, the contents, a floating point number, I'll just get that. I will get a floating point number. So maybe I need to. Oops. Yeah. So what eval is doing is, but if you try evaluating, you get an error actually, because eval only takes in a string. It cannot take in a floating point number or anything and try to evaluate that. But if you gave eval the argument 14.3 within quotes, what Python does is that it treats the contents of the string as if it's a Python expression and evaluates it. Of course, here is just the number 14.3, so the evaluation comes out to be just a number. Now, one question which especially people who have used Python 2 before might have is Python 2 used to have a nice input function where any of this eval etc. was not needed. So yes. If you just said input.
Okay.
Enter a number.
Carry on.
You're back. So
you're back. Okay, no, you carry on. Okay. If you have a serious question there, people have, you go on.
I just wanted to complete this one answer.
Okay.
So x equal to input, enter a number. Suppose this was what Abhijit showed you. Now, if you do this, whatever is coming in, whatever you give from the terminal,
yes,
that's always entered as a string. Now, Python 2 behaved differently. That was because Python 2 actually had 2 functions. One was called input, the other was called raw_input. Raw_input actually returned whatever you gave from the keyboard literally as a string. And what did input do in Python 2? Input actually in Python 2 evaluated that. So the input function in Python 2 was really eval after raw input. frankly, Python 2 was doing two things behind the scenes, and it seemed like a good thing because you give in a number, you get out a number. You type in a number, you get a number. You don't get a string, and you don't have to use eval. Okay. Here, on the other hand, x is a string, and eval x has to be done. So I will just take a couple of minutes to tell you why this change was made. The important thing is, once Python became a much more important programming language, and once a lot more people began writing very important code in it, people realized that this behavior of input could be a problem because somebody might somehow enter malicious code even.
Yes,
So-
yes, exactly.
So some kind of Python code which sort of does something like wipes out your entire directory. That's possible, by the way, to write. You can write it on your own, and if you, of course, want to wipe out your entire directory, that's up to you. The trouble is, somebody might have stored something in a variable, which is a string, whose job ultimately, when evaluated, would be to wipe out your directory or something, do something equally damaging. Now, this is possible to do. It's a security lapse. So that security loophole was plugged by essentially banishing input.
Right.
The Python 2 input function no longer exists. What you call the input function in Python 3 is actually the raw underscore input. Now,
Yes.
when you want to change the input into eval, it's up to you. So you consciously take the decision that you want to evaluate whatever is being inputted. Okay. So that was the real reason for this change. Python 2, of course, was easier in that sense.
Yes.
It was also
For a
prone to
beginner,
attack.
Python 2 is easier in a way.
Yeah, but it was also prone to attack, and that especially for complicated large-scale programs, it could be dangerous.
Yes.
That's why that was changed. So this is
Okay.
basically what I wanted to say.
Okay.
So these questions were raised in the chat, so I wanted to answer them.
Very nice. Very nice. Very nice.
You can take over the presentation. Okay, sorry, you
Okay.
can't take over my presentation.
Urnaboda can hear. Urnaboda can hear. Urnaboda can hear.